Now we'll see the differential operators in different coordinate system from orthogonal curvilinear coordinates. Uh, in terms of curvilinear coordinates, the grade is written as u1 vector divided by h1 dou by dou q1 plus u2 vector by h2 dou by dou q2 plus u3 vector by h3 dou by dou q3. And the divergence is equal to 1 by divergence of v is equal to 1 by h1 h2 h3 dou v1 h2 h3 by dou q1 plus dou of v2 h3 h1 divided by dou q2 plus dou of v3 h1 h2 divided by dou q3. And the Laplacian del squared psi is equal to 1 by h1 h2 h3 dou by dou q1 of h2 h3 dou psi by h1 dou q1 plus dou by dou q2 of h3 h1 divided by h2 dou psi by dou q2 plus dou by dou q3 of h1 h2 by h3 dou psi by dou q3. And the curl is 1 by h1 h2 h3 h1 u1 vector h2 u2 vector h3 u3 vector dou by dou q1 dou by dou q2 dou by dou q3 h1 v1 h2 v2 h3 v3. This derivation is already derived and posted in the previous video in terms of curvilinear coordinates. So these are all things for the curvilinear coordinate. Now from this curvilinear coordinate you can derive it for rectangular Cartesian coordinate, spherical polar coordinate and cylindrical coordinate. So if you take rectangular Cartesian coordinate, the distance between any 2 points is equal to ds squared is equal to dx squared plus dy squared plus dez squared. Now if you compare this with the previous curvilinear coordinate, then you can find h1 is h1 h2 h3 is equal to 1 and q1 is x and q2 is y and q3 is z. And the unit vector u1 is I vector, u2 is j vector and u3 is k vector. Now if you substitute all this in the gradient and divergence and curl, then we can get del psi is equal to dou psi by dou x into I plus dou psi by dou y into j vector plus dou psi by dou z into k vector. Similarly for divergence of v, that is dou vx by dou x plus dou vy by dou y plus dou vz by dou z. That is you are writing vx as vx I vector plus vy j vector and vz k vector. Okay, instead of 1 2 3 you are writing it's x y z. Similarly curl is I j k and dou by dou x dou by dou y dou by dou z v1 v2 v3. Otherwise you can write vx vy vz also. Similarly, for the spherical polar coordinate, consider a point P, and P is a function of r theta phi because spherical polar coordinates are r theta phi. So, if this is your r theta phi, then this r makes an angle r and it makes an angle theta here. And so, if this is theta, so along the z axis it is r cos theta. Along this one it is r sin theta, and similarly this one makes an angle phi with the x-axis. So it is along the x-axis it is r sin theta cos phi, and along the y-axis it is r sin theta sin phi. So we can write x is r sin theta cos phi and y is r sin theta sin phi and z is r cos theta because it is along this z is r cos theta. So we can write this is where x, y and z. Now we can differentiate this with respect to if you want to find out dx, then it is a function of r theta phi. So it is you have to differentiate this with respect to r theta and phi. So it is dou x by dou r into dr plus dou x by dou r theta into d theta plus dou x by dou phi into d phi. So now if you differentiate this, we can get it is sin theta cos phi dr plus r cos theta cos phi dr minus sin r sin theta sin phi d phi. Similarly for dx as a dy and dz. Okay, so by this we can find out what is dx in terms of r theta phi, dy in terms of r theta phi, dz in terms of r theta phi. Now, so it is dx squared is ds squared. The distance between the elements is dx squared plus dy squared plus dz squared. Now you substitute the previously we have derived dx, dy, dz. If you square it, then we can end up with dr squared plus r squared d theta squared plus r squared sine squared theta d phi squared. So from this, what is your Q1? Q1 is your R, Q2 is theta, Q3 is phi, and H1 is 1, and H2 squared is R squared, so H2 is R. H3 squared is R squared sin theta squared, so it is H3 is R sin theta. And also the basis vector is UR vector and U theta vector and U phi vector. And now you substitute all these values in the grade, del and curl. Then we can grade is UR vector dou by dou R plus U theta vector by R dou by dou theta plus U phi vector divided by R sin theta dou by dou phi. So the divergence del dot V is 1 by R squared dou by uh, R squared V of R by dou R plus 1 by R sin theta dou by sin theta V theta by dou theta plus 1 by R sin theta dou V phi by dou phi. So in all the cases, so you have to substitute the value of what is H1, what is H2, what is H3, and what is Q1, Q2, Q3, and similarly for the basis. Then we can get the corresponding coordinates, spherical polar. So delta del psi is 1 by r squared, that is your Laplacian, that is 1 by r squared dou by dou r squared dou psi by dou r plus 1 by r squared sin theta dou by dou theta, sin theta dou psi by dou theta plus 1 by r squared sin squared theta dou squared psi by dou phi squared. Similarly for the gray curl, it is 1 by r squared sin theta UR vector R U theta vector R sin theta U phi vector dou by dou R dou by dou theta dou by dou phi. So VR R V theta R sin theta V phi. So next is for the cylindrical coordinates. Cylindrical coordinates, you take a point P, it's a function of R, theta and Z. So this is your Z, it's may, and this uh, this distance is your r, and this makes an angle theta with the x-axis. So here it is along the x-axis it is r cos theta, along y-axis it is r sin theta, and along z it is z. So x is equal to r cos theta, y is equal to r sin theta, and z is equal to z. And now you differentiate this. So dx is equal to, we can get it is cos theta dr minus r sin theta d theta. Similarly, you can find out what is dy in terms of r theta z, dz in terms of r theta z. So ds squared is dx squared plus dy squared plus dz squared, you know. Now you substitute all the values of dx, dy, dz squared and square it. Then we can get it is dr squared plus r squared d theta squared plus dz squared. So from this we can find out H1 is 1 and H2 is R and H3 is 1, and Q1 is R and Q2 is theta and Q3 is Z, and the unit vector along this is U R vector, U theta vector and U Z vector. Similarly, you substitute all this, we can get del is equal to UR dou by dou R plus U theta vector divided by R dou by dou theta plus UZ vector dou by dou Z. Del dot V, that is divergence is 1 by R dou by dou of R VR by dou R plus 1 by R dou V theta by dou theta plus dou VZ by dou Z. Similarly, Laplacian is dou squared psi by dou r squared plus 1 by r dou psi by dou r plus 1 by r squared dou squared psi by dou theta squared plus dou squared psi by dou z squared. And the curl is 1 by r u r u theta u z dou by dou r dou by dou theta dou by dou z and br r b theta and v z. So from this curvilinear coordinate, you can derive it for Cartesian, spherical, and cylindrical coordinates. Thank you.